Alright, so now we're going to talk about section 1.8 in chapter 1, and this section covers inverse functions. Now, first things first, we need to talk about specifically what an inverse of a function is. It says let f and g be two functions such that f of g of x equals x for every x in the domain of g, and g of f of x equals x for every x in the domain of f. Now remember, these are composites. This is one function inside of another function. So you're putting g of x in place of x in f, etc., etc., etc. And if this is true, then we've proven that the two functions are inverses. So if these two things hold true, the function g is the inverse of the function f, and is denoted by f inverse. That's how you read that. It's not f to the negative 1 power. That's notation. It's not an exponent. So f to the negative 1 is actually read as f inverse. Now that's for function names. So thus, f of f inverse of x equals x, and f inverse of f of x equals x. And the domain of f is equal to the range of f inverse and vice versa. So all that really happens, and we're going to find this out in just a second, is the x and the y change places. Alright, so the first example here is we're going to show that each function is the inverse of the other. Now remember, to prove that they're inverses, all you have to do is do the composite, and if it simplifies down to x, then you've shown all you need to show. So let's do a composite. We're not going to do both of them because we don't actually have to do both of them. We want to just do one. So we're going to do f of g of x. And when we do that, we're going to have this thing right here, 3 times the blob. And in this case, the blob is going to be x minus 2 over 3 plus 2. Now, the blob here is just nothing more than x. So I'm going to put g of x in place of x in f. That's what this means. So when we do that, we're going to go through our operations. First thing we're going to do is multiply, and guess what happens with our 3's? Well, those 3's are going to cancel each other out. So then we're going to have x minus 2 plus 2, the x minus 2 from here, the plus 2 from right there. And then what happens there? Well, our minus 2 and our plus 2 cancels out, and we simplify down to just plain old x. So if f of g of x equals x, then these are inverses. Now I'm going to go ahead and show you the other one as well. So let's do g of f of x. And same idea, we're just going to put f of x in place of x right here. So let's go ahead and write that. We're going to put 3x plus 2. I go ahead and put that in parentheses just because, well, I'm a stickler for stuff like that. And now we can simplify down what's going to happen. Well, if we drop our parentheses, because there's nothing to distribute through, the reason I do the parentheses is, what if this is 2x? Well, then you would have to multiply the 2 times the 3x and the 2 times the 2. Now there's not in this case, but if you get in the habit of doing that, you're not going to miss the parentheses or forget to write them when you need them. Alright, so if we drop the parentheses there, we're going to have plus 2 minus 2, so the 2's are going to cancel out. And then that's going to leave us with 3x on top over 3 on the bottom. And then of course the 3's are going to cancel out, and that's going to leave us with x. So f of g of x equals x, and g of f of x equals x. That, therefore, and that's what these 3 dots mean, that's for therefore, g of x is the inverse of f of x, or you could write that the other way. Either way, they're inverses of each other. Alright, you guys try this one. I'm going to pause the video and I want you to pause the video, and then you can come back and check your work in just a second. So I'm going to pause it, and I'm going to show you the answer here in 3, 2, 1. All right, so here's the work. If you do f of g of x, it should simplify down to x. If you do g of f of x, it should simplify down to x as well. So when both of these simplify down to x, we have shown that these two functions are inverses of each other. All right, now to find the inverse of a function if we don't know it, we are going to have to go through a series of steps. First one, we're going to replace our f of x, or whatever our function notation is, with y in the equation, and then we're going to interchange our x's and our y's. Then we're going to solve for what the new y is. If this definition does not define y as a function of x, the function f does not have an inverse function, and this procedure ends. If the equation does define y as a function of x, the function f has an inverse function. If f has an inverse function, then replace the y in step 3 for f inverse of x, and we can always go back and verify our result by showing that the composites of each of these two functions is equal to x. All right, so let's find the inverse of f of x equals 7x minus 5. So the first thing, I'm going to write this as y equals 7x minus 5. I'm going to swap my x's and my y's. Then I'm going to solve for that new y. So I'm going to move the 5 over by adding it to both sides. And then I'm going to need to divide both sides by 7 to get y all by itself. So when I divide by 7, these are going to cancel out. I'm going to go ahead and flip the sides here, and you get y equals x plus 5 over 7, and it says to use the notation for the inverse. So f inverse of x is x plus 5 over 7. All right, you guys try the same thing with this. I'm going to show you the answer, so you need to pause the video and try it yourself, and then you can check it when I show you the answer in 3, 2, 1. All right, so here's what you should get for your answer. F inverse of x equals x minus 7 all divided by 2. So that's the inverse of 2x plus 7. And if you were told to, you could check that by doing the composite, either f of g of x, or f of f inverse of x, or f inverse of f of x, either one. All right, so let's find the inverse for f of x equals x cubed plus 1. Same idea, just looks a little different. So we're going to have y is equal to x cubed plus 1. And we're going to swap these. X is equal to y cubed plus 1. We're going to move the plus 1 over, so you get x minus 1 is equal to y cubed. And we're going to take the cube root of both sides. When we do that, we're going to get that y, and I'm flipping sides again, is equal to the cube root of x minus 1. Now, here's the situation that we need to ask. Is this a situation where we've got more than one y value for any given value of x? If we plug an x in here, is there any x we can plug in there that we're going to get more than one different y value? And in this case, there's not. So f inverse of x is equal to the cube root of x minus 1. So we don't have that plus or minus thing when we're taking an odd root. If this had been square root, it's another story. But because it's an odd root, we're okay. All right, you guys try this one. I'm going to pause the video, or I'm going to show you the answer. You need to pause the video and try this, and I'll show you the answer in 3, 2, 1. Alright, there's the answer. We're going to put in y for f of x. We'll swap the x and the y. We'll solve for the new y. And I went ahead and flipped my sides right here before I took the cube root. Then I took the cube root of both sides, and the cube root of y is just going to be y. There is no plus or minus with a cube root or any odd root. And then the cube root of x plus 1 over 4 is just the cube root of x plus 1 over 4. So there is your inverse right there. Alright, so let's try this one. We're going to have y is equal to 5 over x plus 4. And we're going to move the 4, we're going to exchange the x's and the y's. We got x equals 5 over y plus 4. Subtract 4 from both sides, so x minus 4 equals 5 over y. Now, the little trick here that you can do is you can actually multiply both sides by y, but there's another way you can do this. You can think of this as being over 1, and if this fraction is equal to that fraction, then guess what? The reciprocals of both fractions are going to be equal as well. So where I've got 5 over y here and x minus 4 over 1 here, I can rewrite that as 1 over x minus 4 is equal to y over 5. And then all I have to do is multiply both sides by 5, and I'm going to have 5 over x minus 4 is equal to y. And if I change sides and write that with, and that's 1 to 1, so f inverse of x is equal to 5 over x minus 4. What I mean by when I said that's 1 to 1, for any given value of x, I'm only going to have one y value out. That's what I mean. It's a function. Alright, you guys try that one. I'll show you the answer in 3, 2. Alright, so here's the answer. F inverse of x is 3 over x plus 1. And what that means is that that is the inverse of this thing right here. And of course, you could always do your composites, put those together and double check it. So if you ever are not sure that it works out, do your composite if you're looking for an inverse. If the composite does not simplify down to x, you don't have the inverse. All right, now the horizontal line test and one-to-one functions. We know that we've tested to see whether or not a function or relation is a function by using the vertical line test. And what that tells us when we draw that vertical line, we've talked about that before, that line is representing an x value. And if we only hit one place on a graph, that means there's only one y value for any given value of x. That's why when we take that thing and we slide it across, if I can select it, there we go, and we slide that thing across, we're checking all the x values at once. That's what we're doing in our head. Now, let's see what happens if we try to find the inverse of the standard quadratic function f of x equals x squared. Well, we're going to have y equals x squared. I'm going to swap those two. Oops, sorry. X equals y squared. Then we're going to solve for y, and we're going to end up with y is equal to, when we take the square root, that's where we have the whole plus or minus thing. So when we have the plus or minus, we're actually getting two values of y for one given value of x. For instance, let's say x equals 4. If I plug a 4 in right here in this side of the equation, guess what? What's the square root of 4? Well, the square root of 4 is 2. So I have a positive 2 and I have a negative 2. So that's where we get two given y values. So if x is equal to 4, I actually get a y value of negative 2 and a y value of 2. Two y values for one given value of x means it's not a function. So the plus or minus in the y equals plus or minus x shows that for certain values of x, all positive real numbers, in other words, there are two values of y. Because this equation does not represent y as a function of x, the standard quadratic function f of x equals x squared does not have an inverse function unless we limit it. But we're not talking about that right now. All right, so that brings us to the horizontal line test for inverse functions. Remember, with an inverse, the x's and the y's just swap places. So while we took and did the vertical line test for functions, and all these pass, what we're doing here, if we're checking to see if the function or the inverse will be a function as well, if x's and y's change position, that means horizontal and vertical change position. So we actually do a horizontal line test. When we go up through there, for any given value of what? Y, our line is measuring the y values. For all values of y, there's only one x value that goes along with it. And when I move over here, what happens? Well, this thing violates it all over the place. And this, of course, is one of those square roots. It just happens to be one that's opening down. So that one fails. This one fails. And this one over here actually passes. And that's what we mean by one-to-one. If it's one-to-one, it does two things. It passes the vertical line test and becomes a function, and it passes the horizontal line test to prove to us that the inverse of that function would also be a function. So this passes, well, let's say inverse function. So its inverse will be a function. This one was no. This one was no, and this one was yes. I don't know why I'm writing two S's with me. So which of the following graphs represent functions that have inverse functions? So all the outside ones, this one and this one, are yes. These in here are no. Now, be careful. It has to pass both tests to be one-to-one. All right, find the inverse of f of x equals x squared minus 1 if x is greater than or equal to 0. Graph f and f inverse in the same rectangular coordinate system. Now, if we're only letting x be greater than or equal to 0, think about what the graph is. If x is only greater than, x squared minus 1 is a parabola. It looks like this, but if we're only doing values of x that are greater than or equal to 0, we can get rid of that side right there. So we're only talking about this value over here, this part over here. So, does that pass the horizontal line test? Well, first of all, does it pass the vertical line test? Is it a function? Yes, it would pass the vertical line test. And then if you took and did a horizontal line in there, would it pass the horizontal line test? Yes, it would as well. Therefore, we know we're going to have an inverse function here. So when we go to find this, we're going to do what? Well, we go ahead and we solve it exactly like we normally would. So you're going to have y is equal to x squared minus 1. Change the locations, y squared minus 1. Move the 1 to the other side, so we're going to have x plus 1 equals y squared. And then what do we know? We take the square root of both sides. Square root of x plus 1 equals y, or y equals the square root of x plus 1. Now, guys, if we did plus or minus here, we would end up doing what? We would end up having a function that's whose inverse is not a function. But right now, what do we know about this function right here? Because we only have the positive, we're going to reflect this thing. Remember, an inverse, we're going to talk about this in a second, but you should already know this. An inverse actually reflects across the line y equals x. That would be the green line here that I'm about to make dotted. So that's the line y equals x, and everything that we've got here for the inverse, x and y's change position, it means it's going to reflect across this. So when I go to draw or to think about this graph, the red, this point right here is going to go right over here. Because right here, this is 0, -1, this is -1, 0. See how the x's change position? And then this one over here, whatever it would be, is going to be up here somewhere. So specifically, this point is 0, -1, and this point over here is -1, 0. And we're going to graph something that looks like this. Ooh, that's awful. I went too far up with that point. That's what it was. And notice right here they share the exact same point, because at that point right there they're both crossing the line y equals x. So it's not, there's no change over that one. Now, here's the thing, is that the positive square root of x plus 1, or is that the negative square root of x plus 1? Well, positive would be above the x-axis, negative would be below, so this is the positive. You don't have to put the plus in there. I would just put it in there just to confirm that yes, it is the one that I'm looking for, it's the one on top. If it had been down here, the reflection, then it would be minus. Alright, so you guys work that one out. It's still going to be the plus, and you're going to do the subtraction. So pause it and work it out and see what you get. And check your work. Alright, so this one right here, same situation. We're still going to be above it. And I want to go back for just a second and show you something. If we had done, when we did the square root here, in all actuality, this is still plus or minus. But because we're the reflection only on top of the x-axis, that's why we can limit ourselves down to just the plus. Remember, anytime you're taking the square root, it's always going to be plus or minus when you're solving for all the solutions, until you can get rid of some of the solutions. And in that case, we could get the negative square roots all out of the way. Alright, so the answer for this one is going to be y equals plus or minus the square root of x minus 1. And which one is it going to be when you look at the reflection? Well, it's going to be the plus again. That's it.